Good afternoon, everybody. Thank you so much for spending your Tuesday afternoon with us, or late morning if you're out on the West Coast. My name is Maura McGinnis, and I am the Northeastern Regional Manager for QTran, located in Milford, Connecticut. And you've come to join us for our Tuesday series of Q School Online. So thanks so much. We know that you're spending a lot of time in front of your screens. I am joined today by my friend and coworker, Tyler Tremaine. He is our Eastern Regional Sales Manager. He's located in Georgia, and he has chosen a very fine wallpaper for his living room.
How are you?
Good.
Again, I am Tyler Tremaine, and I am the Eastern Regional Manager based here in Atlanta. I wanted to thank all of you for joining us today for Q School. We'd like to get started talking about our static white LED strips. But before we do that, I wanted to briefly take a look at our website to show you some of the options available to find all of our information. So up at the top, we have the product section. And if we go down to the linear LED strips, here we'll see all of our linear strip options. And by filtering here on the left, you can narrow down to just the static white. And as I go into one of our static white choices, I'll show you where you can find all of the information. We highly recommend, if you're going to choose just one option, to go to the ordering guide. But there is more information here available, including this all download section that'll have the IES files in PDF format or the IES format available for you for all of our LED strips. So let's get started. I wanted to talk a little bit about the mechanics, or what makes up the components of a flexible LED strip. But before we do that, I wanted to point out this beautiful picture that was specified by Gary Steffi Lighting Design. And this is the Smithsonian in DC, and the beautiful handrail job they've done. So as we get started, the components of a flexible LED strip start with the board, or printed circuit board. The PCB is designed for the best thermal management. And atop that, the PCB board, the LED chips and the resistors are placed onto the strip. Another one of the factors that make the differences, in the LED strips are the cut points, which is the smallest increment of the LED, and also the pitch. And the pitch is the distance between the LED chips. So let's take a look at the cut points and the size of the LED chips. So looking here, our competitors typically have cut points that range between 1 inches and over 6 inches. The larger the cut point, the more difficult it'll be to build a finished fixture that is very precise for your projects. Another one of the features I want to show here are the different size of the chips. So the 4-inch cut points in this example has a large 50-50 chip. And as we can see, even behind a diffused lens, the spacing, or the pitch, plus the size of the chips, do give a large pixelation. As we work our way down from these images, the 2-inch cut point has slightly smaller chips and smaller spacing, but the bottom picture with the 1-inch cut points is our most recent LED with the smallest chip and smallest spacing. And as you can see, it is a diode-free result behind the diffused lens. Let's take a little bit closer look at QTran's LEDs.
Before we jump into this slide, let's talk about that pitch point and that consistency, which you are going to get to, but we'll give you a little demonstration. I have on the table I have lots of stuff on this table, by the way, a lot of color. So I have a 5 watts a foot, an old chip process that we used to do, and a larger chip. This is actually our 7.5 watts a foot. But it should be really important to remember that QTran is a power supply company, and we're really proud of our roots. And where we came from over 25 years ago was good performance, good design light output and good dimming, right? So one of the reasons why our 1.5 watts a foot to 5 watts a foot are consistent in that really tight pitch and that small 2016 chip is to get consistent color and consistent dimming. So for everybody who's on this call, whether you are a rep or a specifier, we have a great sample case, and we are happy to ship these out to you to your home offices or ship out samples as needed. But inside this case, we have our IQ PH80, and we have this great torque extrusion with our 4 standard lenses. This is a very popular extrusion. And 3 different wattage fixtures. You're going to see the fact that you'll have 3 different brightnesses and a consistent dimming curve across those 3 brightnesses. So I'm going to turn them up to the camera. I am going to actually turn them towards myself and cover the LED part, hopefully. Well, it's still very glary, but you can see 3 different illumination levels. They're all at full, and I'm just going to hit the down button, maybe with the other hand, so you can see that they dim on the exact same curve. So what we've done there is we've engineered the PCB and the resistors, but kept the chip spacing, the chip color consistent. So you're going to get consistent color and consistent dimming across wattages 1.5 to 5. It's also 1 step, 1 bin, which we're going to talk about a little bit more. But I wanted to jump into that before Tyler got to the entire line, because that's really important in our static white series, our SW24 series. Okay, Tyler,
Thank you very much, Maura.
You're welcome.
So as you mentioned, the 1.5, 3, 4, and 5 watt per foot static white, all dim the same. They're all the same boards, same chips, just different resistors. And these are our smallest cut points at 1 inch. We also have the static white in 6.0 and 7.5 watts per foot with a 2-inch cut points. And then our new high efficacy LED tape with 6 and 9 watts per foot are also 2-inch cut points. And we're going to talk about a little bit more about those later.
Before you move from this slide, on the top left, you see that 1-inch cut point has 6 diodes, and the 2-inch cut point has 6 diodes. This again helps us with consistency in the dimming curve. They're different size chips, but they've been engineered to dim on the same curve regardless of wattage. Then you get to the HE, which has more chips per 2-inch cut point. We're pumping out more lumens. Okay.
Thank you, Maura. So this is a beautiful project here specified by Christian Ray Studios to show some of our beautiful static white LED tape. Wanted to talk a little bit about 1 step, 1 bin. So if you're looking for the best possible light quality with consistent results for your product, you need to use our 1 step, 1 bin LED strips. The 1 step, 1 bin provides a very consistent results against different projects. That 1 step is only a 30 plus or minus 30K CCT between any of the different chips. The eye is unable to see the difference between a 75K. So it's a very small change. So the products here offer exceptional quality, light quality.
Right, and it should be noted, I think there's a lot of great information from plenty of manufacturers and science about the McAdams ellipse and about the black body curve. Our engineers are able to standardize our testing across a certain milliamp and a certain wattage. So we can give you more information about the science behind how we're able to offer a single step in a single bin LED. It's just a higher quality, and it helps us really be consistent in the delivered light quality, color, CRI, R9, the whole range. So,
thank you, Maura.
You're welcome.
Let's take a little closer look at all of Qtran's static white LED strips. All the information below is at 3000 Kelvin with a dry LED tape. So as we look at the CRI, or color rendering index, all of our strips are above 96. As we look at the CRI R9 values, which is the way that red is rendered, all of our static whites are above 93. And as we go on to the TM30 information, The IES described this as TM30 provides a robust suite of metrics that convey much more information than any previous attempt at characterizing color rendering. So the TM30 information is sort of the newest way of evaluating light quality, and it gives much more information. So the RF is the fidelity, which is the similarity to reference source for all colors. And this is a 0 to 100 score, with 100 being the best. And all of the QTran static white LED strips are 92 and above. And the RG is the gamut index. And this is the average change in chroma for all colors. And the scale is between 0 and 150, with 100 being the center point or ideal number. And as you can see, all of the QTran static white LED strip are between 99 and 101. So we're all very, very close to these numbers. Let's take a look at one of our cut sheets available online in the ordering guide section. So this is our static white 24 5.0 3000 Kelvin information. So as we can see here, we give all of the information: the CRI, the R9, the TM30 fidelity, TM30 gamut information, and then each of the individual R, Q, and C values if you're so interested in all of our details. This information is available on all the color temperatures for all of our static white LED strips.
So, right, so just as a reminder, that's what, oh, you're going to go to it, a comparison, but that's why we're always sort of reminding the spec sheet is great for building a part number, and we're going to talk about that as well, but the average 12-page ordering guide has mounting instructions, installation instructions, lots of different IP and temperature, all sorts of information, but especially all these color metrics. And we're really adamant, insistent about using that document, because it just gives you all the data that backs up our quality and why our LEDs are superior to other LEDs in the market. And with that, Tyler has a slide coming up to compare.
So we're taking a quick look at one of QTran's static white LED tape versus one of our competitors. So as we can see, the CRI values between the two, QTran is at 97.8 versus an 80.6 for our competitor. The R9 values are a huge change. So QTran is a 95 out of 100, but our competitor is only a 22 out of 100. The TM30 fidelity information, 93 versus 82. And the gamut information, or index rather, for QTran is 100 versus our competitor is actually 0. We were unable to find this, so we apologize for that typo. Let's take a look at some of the...
And again, sorry to keep harping on this, but for our Title 24 designers and specifiers, DUV is becoming more and more critical. So the fact that we're testing for that and publishing that is important. So
thank you, Maura.
You're welcome.
So QTran's LED strips are custom to our specifications with superior light quality and small cut points, as we've just discussed. We also have the ability for custom assembly of LED strips at the factory, can populate the boards with the chips and the diodes to fulfill custom orders or meet tight deadlines. Let's take a look at the surface mount technology, or SMT machine, at work in the factory in Connecticut.
So this is available on our website under Gallery. We have a header on our website called Gallery with lots of videos. So I think Tyler is going to play it for us. And I'll narrate because it is on our website without sound, I believe. So this is here in Milford, the SMT machine. You can see it's its own room. Starting at the far end, and we go a little out of step in this video, but you have stenciled sheets, which are the LED strip itself. The LEDs are populating on the board by a robotic arm. That's actually working at about 1/5 speed. So this is just for the video, obviously. See how it's picking the LEDs? It's a pick and place, sort of, off of the spool, setting them on the PCB. The PCB is then sent through an oven to electronically and heat secure. Then the sheets, which are individual strips actually, are soldered together by a robot to make your long lengths, right? So if you have a 10-foot strip of LED, all the stencils are those rectangles. They're never going to be a 10-foot long thing. So instead, you have these sheets, and then the solders are all put together to get your big lengths, right? So either by robot or by hand, these are always soldered together to be longer and longer and longer. So it's super cool, by the way. So for those of you who have not visited our factory, please come and see us because it's pretty neat to see this stuff working. But like Tyler said, what it allows us to do is populate our own boards when necessary, and also to create custom and modifications when needed. And that does happen. As you know, designers and specifiers, and we have that capability here in Milford, Connecticut. So that's a cool, our SMT machine's pretty neat. Other stuff is on that website gallery, so take a peek around our website. And what is next, Tyler, after SMT of how boards are made? Is it color temperature?
We're going to talk about board identification. So new for 2020, Qtran has now started printing all of the color temperatures and wattages on the boards to help with identification. Our customers had expressed to us that at times with multiple color temperatures or multiple wattages that sometimes on the job site they had difficulty figuring out which is which. So listening to our customers, we have now added this feature to all of the boards. And now that we've discussed the physical properties and the light quality of the static white LEDs, let's investigate the options for each of our strips. So here we have a snippet of one of the cut sheets, and this is the SW24 3.0. So looking from the left to the right, we indicate which strip this is, followed by the environmental rating as we go to the right. And I'm going to talk a little bit about that in a moment. Followed by the color temperature, which also gives the lumens and the CRI for each of these. Then we have the wire connectors in or out of the LED, and that is part of corresponding with finished fixtures, which we will talk about in an extrusion webinar coming up shortly. And then followed by the length. So the maximum length for each of these static white LED strips is set by the Class 2 limitations for the National Electric Code. So 96 watts is the max. So for this LED tape, the max would be 32 feet. So let's take a look at each of these options a little bit more closely. So looking at the environmental ratings, the dry, which is IP20, is the unchanged LED strip with the chips and the resistors on top. The next option is damp, and this is an IP54 option. And what we've done is encapsulated a bubble on top of the chips and the resistors to give it a little bit more water resistance. The maximum length we can do for this damp option is 180 inches or 15 feet as we use our encapsulation machine, which is how we make our QCAP products, which you may have seen in a previous webinar, Q School. And then finally, the wet option. So this is an IP68 rated strip, and it is enclosed in a non-yellowing silicone sleeve. This is limited to 30 feet or 360 inches, just as it's difficult to pull the LED through the actual sleeve itself. So next, let's take a closer look at the color temperatures available for each of these.
Yep, so as you can see by that graphic, we offer 2,000 to 4,000. I'm going to show a few of them just because I have all my son's old toys here because I wanted to pop up the room a little bit. I'm just going to give you some warmest and coolest. So for our 2,000, that's a really nice warm amber. And I'm going to turn that on, and I'm going to show it to you on some reds. So these are 3 watts a foot in our Lalo extrusion. It's one of our newer slim extrusions. So you can see that red is super warm and really nice. Then I'm going to give you our 4,000 to go with our extreme on that and pop it on those blues. So those blues and greens just really pop. The reds gets a little dull. And I think probably you couldn't see what I was doing, so my apologies. So I'm trying to not blare it at the camera, but also show you the colors. So the red gets a little flat, but the blue is really nice and poppy. Ooh, and running away from me. There's the nice blue and this blue scarf. And I'm going to then go back to that 2000, which makes that red really rich, but sort of deadens that green. That New York cab, though, that's looking pretty sweet in that 2000 Kelvin. So 2000, 2200, 2400, 2700, 3000, 3500, and 4000. We have them all available. In your sample kits, all color temperatures are shown in bare LEDs at 5 watts a foot, and all wattages are exhibited in 3000 Kelvin. So hope that's crystal clear, but those are in the kits. So Tyler, I just want to be cognizant of time and make sure that we talk about our new stuff.
So we've got some information here on our new high efficacy strips available in 6 and 9 watts per foot. Both of these static white LED tape are one step, one bin. They use the same chips in the same spacing, the same idea for our 1.5, 3, 4, and 5 watts a foot we talked about earlier. These new high efficacy tape have a 2-inch cut point, and they're available in the same color temperatures that Maura had mentioned: 2000, 2400, 2700, 3000, 3500, and 4000 Kelvin. As we look at some of the lumen output for the 9 watt per foot, at 4000 K, you'll see that this tape has 1,192 lumens per foot, so extremely bright. How does the high efficacy strips compare to our standard static white 6.0? Let's take a look. So here, looking at the pictures on the bottom left, you'll see an image on the left of our standard static white 6.0, and on the right is the high efficacy 6.0. So as you can see, it is much brighter in the image. And as we move over to the box on the right showing all of the statistics, we'll see that the cut points are similar. The high efficacy has 8 LEDs per cut point instead of 6 on the standard 6.0. The CRIs are exactly the same. The R9 values are extremely close. Same with both TM30, fidelity, and gamut information. But you'll notice the large difference is the very bottom is the lumens per foot. So the new high efficacy is about 50% greater lumen output than our standard 6.0 LED tape.
So I do want to just point out, go back to that slide.
Sure.
I just want to point out that on that left and that right, you can really see at the foreground of the picture, it's diffused, and at the far on the wall is a clear shot. So we're giving you to sort of show you the beam. It's in our torque extrusion. And I just want to point out that the reason we did that so we could really see that texture moving up that image. So I just like to, moving on from there. I just wanted to share that.
I'd like to preview our next 2 high efficacy options, which will be a 1.5 watt per foot and a 3 watt per foot. As you'll see, the 1.5 will have 222 lumens at 3000 K, and the 3 watts per foot is over 400 lumens per foot at 3000 K.
The static white high efficacy 1.5 and 3.0 we have not released yet. We are looking towards, you're all the first to know. They're going to release probably in mid to late May, so you can keep an eye out for that. And again, please be cognizant that the high efficacy products have 8 LEDs per cut point, and the static white have 6, and different chip sizes and different chip spacing. It only becomes critical when you're using them next to each other for any reason, but it's something we like to point out because although the consistency of color and quality is still great, the bones of the product are a little bit different. So you're regional and can talk to you about it, and we're going to get samples out, so please request them. Okay. Thanks, Tyler. Everybody, please stay safe. Again, we know you're spending a ton of time in front of your screens, and we appreciate the time you're spending with us. Please reach out. We have lots of webinars on the docket. This is our Tuesday activity here at the factory, and your regionals are all working and available. The factory's here, and however we can support you in this time, we're happy to do so. Thank you so much for all your support over all the years, and everyone stay safe. Thank you.
Thank you very much, everybody.